All right, so peace algebra. So one thing that we talked about in class was that we had to go back and review some things about inequality. So we pretty much talked about all the different things that we need to know about inequalities, but we haven't talked about how to solve inequalities that involve the absolute value sign. So it says, how do you solve inequalities that include or involve absolute value? We all know that, or we should know, that absolute value just means the distance from zero. So if I have the absolute value of 3, we're going to talk about that 3 is 3 units away from 0. Or if I have the absolute value of -3, that's still 3 units away from 0. So the first definition that we need to write down says absolute values inequalities that deal with less than. So for instance, if I have the inequality, if I have the inequality, the absolute value of x is less than 3. So if I have the inequality, the absolute value of x is less than 3, this means the distance this means the distance between x and 0 is less than 3. Okay, so the absolute value of x is less than 3. This means that the distance between x and 0 is going to be less than 3. So when we're solving these problems, we have two cases. Case number 1 says the expression inside the absolute value symbol is non-negative, which means it has to be positive. Case 2 says the expression inside the absolute value symbol is negative. So the solution for these problems when we're talking about, and for case 2, is going to be the intersection of solutions of these two cases. So if I look at the first example, I have the absolute value of m plus 2 is less than 11. So we have to rewrite this for both cases. So let's rewrite this for case 1. Case 1 being that it is non-negative. So if I rewrite this for case number 1, and it's being non-negative, I have m plus 2 is less than 11. Now we know how to solve this inequality like regular. I have to subtract 2 on both sides, and then I'm left with m is less than 9. But now this is the difference. Let's talk about when I have to subtract this by, or for case 2, when m is negative. When it is negative, I'll take a negative, and let's do m plus 2 is less than 11. Now, I want to get rid of the negative on the outside. So let's divide that whole thing by -1. If I divide it by -1, remember I have to do m plus 2. My sign is going to change, and this becomes -11. So now let's solve this. I have to subtract 2 on both sides, and then I get m is greater than -13. So I have m is less than 9, and m is going to be greater than -13. So if I write that, I should have -13 is less than m, which is also less than 9. If I were to graph that, I have -13 over here, and I have 9 way over here. So remember, the graph is going to be the intersection of all of that. So that's all it means when I'm graphing or when I'm solving these problems with inequality symbols. So now let's go ahead and look at page 2. I want you guys to try example 2 on your own, and then we'll talk about this in class tomorrow. If I look at page 2, now I have absolute value inequalities with greater than. So if I give you that same definition and I say that inequality the inequality, the absolute value of x is greater than 3, this means that the distance between x and 0 is greater than 3. So once again, case 1 means what happens if the inside of the absolute value symbol is non-negative, or if case 2, the expression inside the absolute value symbol is negative. So just like before, I have to go ahead and set up my problem for case 1 and case 2. So looking at this problem, if I have 3n plus 6 is greater than or equal to 12, case 1, remember case 1 means it's non-negative. So case 1, let's set it up. 3n plus 6 is greater than or equal to 12. In order to solve this, I got to subtract 6 from both sides. I'm left with 3n is greater than or equal to 6. Let's divide both sides by 3. And I have n is greater than or equal to the number 2. All right? Or if I talk about case 2, remember this means if what's inside is negative. So let's go ahead and put our negative sign. And then on the inside I have 3n plus 6 is greater than or equal to 12. Remember, I want to get rid of that negative sign, so let's divide by -1. So I will be left with 3n plus 6 is going to be less than or equal to 6. Remember to switch my sign. Is less than or equal to -12. So now solving this, I have to subtract 6 on both sides. And then I have 3n is less than or equal to -18. To finish this up, I need to go ahead and divide both sides by 3. And then I'm left with n is less than or equal to -6. So if you notice in this problem, when I wrote it, we wrote or instead of and. So this time, let's graph that. If I graph it and I have n is greater than or equal to 2, so over here is 2, closed circle, pointing to the right. And then on the left, I have -6, still closed circle, but this time it's pointing to the left. So the only thing that's really important that's different from what we learned is you guys just have to pay attention to the cases. So as I said before, when we talk about inequalities that deal with less than, they're going to be the intersection. When we talk about greater than, it's going to be the union. When we're solving these problems, it's very important that you guys solve for both cases 1 and case 2. So what I want you guys to do is let's go ahead and try example 2 on your own, and then we will talk about this tomorrow in class. And please do not forget to write your summaries. I will be giving credit for your summary. In order to receive full credit, it must be filled out. Remember, we talked about say, do, mean summaries. What do my notes say? What procedures do I do? And what do my notes mean to me? Have a good evening, guys.